All right, welcome back to another algebra state test prep video. Today we're talking about standard S.ID.1. And if you're watching these chronologically, we have finally hit the final family of standards that would be statistics. So, here we go. A landscaper records the heights and feet of 15 newly planted trees in a community garden as shown, and they list 15 sets of data. Complete the histogram by selecting frequencies for the heights of the newly planted trees in the community garden. So you see your histogram goes from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So I would just put things that start with 0, things that start with 1, 2, 3, 4, 5, 6, and 7. And we're going to make tallies. Okay? Because this is the easiest way to do it. 3.2 starts with a 3. 4.3 starts with a 4. 3.5 starts with a 3. 5.4 starts with a 5. 3.7 starts with a 3. 5.5 starts with a 5. 6.2 starts with a 6. 3.1 starts with a 3. 6.8 starts with a 6. 7.1 starts with a 7. 4.8 starts with a 4. 6.5 starts with a 6. 4.9 starts with a 4. 5.3 starts with a 5. And 5.9 starts with a 5. And now I will quickly check to make sure I've made 15 tally marks. 4 plus 3 is 7. Plus 4 is 11. Plus 3 is 14. Plus 1 is 15. Okay. So, we're going to talk about how a histogram should look versus what you're going to have to do on a state test. On the state test, if you have 4 tally marks for 3, all you're going to do is you're going to go to the 3 column, and you're going to click 4. And that'll automatically put it. Okay? On an actual histogram, how it will look is like this. Okay? There are 4 heights between 3 and 4. So this would go up to 3. This would go up to 4 and cover between 3 and 4. You'd probably have to click here, maybe actually. There are 3 heights between 4 and 5. There are 4 heights between 5 and 6. There are 3 heights between 6 and 7. And there is 1 height between 7 and 8. That's how it will look. I imagine you might have to click like in the middle of these spots. I'm not quite sure how it works, as I've not taken the Ohio State test, but I would imagine that's probably what it looks like. At the end of the day, your graph should look like this. All right, question 2. This is going to be impossible to all fit on one page, so we're going to have to do this as we go here. Data comparing the number of calories in chicken and beef sandwiches from different restaurants are displayed in the histograms below. Okay. Then we need to figure out which pair of box plots for chicken and beef sandwiches could represent the data in the histograms. Okay. So, histograms and box plots are 2 different ways of showing data. Okay. The box plot focuses more on what's called the 5-number summary. The box plot focuses on making a box like this. With 5 dots. This represents your minimum. This represents what's called Q1, or your first quartile, your lower quartile. This represents your median. This represents your Q3, or your upper quartile. And this represents your maximum. These are the ways that we show data on box and whisker plots. Okay? These histograms don't show us exactly what numbers these are. However, we can still make several inferences off of it. Okay? We know that the lowest number, the minimum, for chicken sandwiches and beef sandwiches will fall somewhere between 50 and 100. Okay? So if there's any that have a minimum outside of 50 or 100, which sadly is not the case, we would be able to eliminate off of that. we know that there is one single thing, one single beef sandwich that hits between 300 and 350 calories, while there are more chicken sandwiches that do so. So first we need to check if there are any of these things that don't have the maximum for chicken or beef falling between 300 and 350. Plot A has a beef sandwich maximum of 250. The fact that we do have one here between 300 and 350 means the maximum needs to be somewhere in this area, so A is wrong. B has the maximum of chicken sandwiches being 275 calories. That is again saying that is our maximum. And we know that, we actually know this goes up to 250, 300. I stand corrected. That's fine. Okay. C is fine based off of our maximums. D is again not fine because it says your maximum for beef sandwiches is 250, which we know is impossible. So now we've narrowed it down to C and B. So we got to try to figure out how we can distinguish. So when you look at what Q1 is essentially the median of the lower half. And Q3 would be the median of the upper half. So if we try to figure out, let's see how many of these sandwiches we have. We have 5, plus 4 is 9, plus another 4 is 13, plus 1 is 14, plus 1 is 15. Okay, so we took 15 sandwiches. I believe this one will also end up being 15. 2 plus 5 is 7, plus 3 is 10, plus 2 is 12, plus 3 is 15. Yeah, so we took 15 sandwiches from each restaurant. So you would see, if you look at beef sandwiches, and this is one of the most confusing questions I've ever seen on this state test. You would see, if you look at beef sandwiches, that 13 of our 15 beef sandwiches fall before 200 calories. What does that mean? Okay, so that would mean that if you took the 15 samples, so let's just, I'm not going to actually write, but let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? I've messed this up terribly. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Your median would fall as the 8th value. That would be the middle spot. Then your Q3, 1, 2, 3, 4, 5, 6, 7. 7. Your Q3 would be the 12th value. And your Q1 would be the 4th value. Okay? Your 12th value of beef sandwiches will fall somewhere between 150 and 200. So I'm looking to see if one of these has a graph where Q3, that's this end of the box, falls between 150 and 200 for beef sandwiches. There it is right here. Where does it fall on the other graph? All the way up in 250. This is impossible because 250, there's only 1 out of 15 that is more than 250. Therefore, this cannot be possible. It is B. I hate this question. This question is very difficult for me to explain personally. I'm not sure why, because it makes sense a little bit in my head, but it's hard for me to get out onto paper. If you want me to talk about this question more in class, I absolutely can. But this question is... Question 3. Jarrell keeps track of the number of customers that come to his bakery every day for 1 month. Summary of the data is shown. Which box plot represents the data? So, remember in box plots, we just talked about the 5-number summary. Minimum, Q1, median, Q3, maximum. Mean does not matter for this question. Mode does not matter for this question. We're looking for a box plot that has a minimum of 32. This box plot has a minimum of 50. Not it. This box plot could conceivably have a minimum of 32. All right? This box plot could conceivably have a minimum of 32. Okay? This box plot has a minimum of 0. Doesn't work. Let's check the maximum. Maximum is 103. This box plot could conceivably have a maximum of 103. This box plot could also conceivably have a maximum of 103. Let's check the median next, because if there's one thing I can tell is in a different spot, it's the median. This median is hovering around 77. This median is hovering around 69. Our median is 77.5. This median is less than 70. Can't be that. Therefore, it's B. So that'll do it for this standard. If you have any questions, feel free to let me know. Otherwise, good luck on your state test.